Dear children, I welcome you all to class 9 for the session 2020-21. Today is our first class and in this we are going to start the chapter motion. So before that, let us see the syllabus. This is chapter number 8 and you can see the subtopics: describing motion, motion along a straight line, uniform and non-uniform motion, measuring the rate of motion, speed with direction, rate of change of velocity, graphical representation, distance time graph, velocity time graph, derivation of kinematic equations, graphical method, uniform circular motion. So moreover, we have to cover these 4 chapters also: force and laws of motion, chapter number 9, chapter 10 gravitation, chapter 11 work and energy, chapter 12 sound. Okay, so let's start. In lower class already you have learned 4 different types of motions, namely linear motion, circular motion, rotational motion and periodic motion. So then how do we describe motion? To describe motion, you have to learn about what is reference point. I don't know whether you have learned in lower class or not, but now you need to know reference point or origin. Say example, you are standing at a distance 5 meter from a wall. So if I ask what is your position, if you say that you are standing at a distance of 5 meter from a wall, then that wall is the known point which I consider as the reference point. If I know the position of the wall, definitely I will be able to know about your position. So that is what is called reference point or origin. So if you want to describe the motion of an object, first you have to consider a reference point or origin. Okay, so normally we can say motion, you see, the state in which an object or person is moving is called the state of motion. Similarly, rest, you see, the state in which an object is not moving is called the state of rest. So for an object that is simply lying on the ground, we say that the object is in the state of rest. So this is how to define uh, motion of an object. So more precisely, you can define motion of an object by saying that the object changes its position with respect to some reference point. Fine. So how will you define motion? So you should be able to define motion in terms of the reference point. That is, you will say that when a body changes its position continuously with respect to a fixed reference point, then we can say that the body is in motion. If the body is not changing its position with respect to that reference point, then we can say that the body is at rest. Fine. So that is one thing. Second is motion along a straight line. Already I told you that these you have already learned in lower classes, but there is a new term related to this, that is what is called rectilinear motion. The motion in a straight line is also called rectilinear motion. You can see I am drawing this line. This is a number line and there are points O, C, B, A. An object is moving along a straight line. You can see this here. Say an object is moving from O to C, C to B, B to A, or coming back from A to B or B to C, whatever. So the object, we can say that the object is in motion along a straight path. So I can say that the motion is rectilinear or linear. So I am putting one example here. I want you to read this and you understand this. Next is distance. Now distance, you can see the definition first. The magnitude of length covered by an object is known as distance. So while coming from home to your school, you have to follow a certain path. Now, say example, you are uh, moving from um, home to your school, or you may go back from school to your home following a certain road. Now, what is the length of the actual path followed by you? That is called distance. So you can see the magnitude of length covered by an object is known as distance. It is actually the length of the actual path followed by an object. Now distance may vary. The distance between two places may vary. Say example, you are moving from Numaligarh to Jorhat. So you may follow uh, directly from Numaligarh to Jorhat also, or you can go from Numaligarh to Jorhat via Golaghat also. So in both the cases, distance covered by you is not same. So it depends on the length of the path. Okay, so it depends on the path followed by the object. It depends on the path followed by the object. So what is the actual length of the path followed by an object is called distance, and unit SI unit is meter. SI unit of distance is meter. You have learned about three different types of units: MKS, meter kilogram second system, centimeter gram second system, and foot pound second system. So MKS system is internationally accepted, so that is why that is also called system internationalized, and that is also called SI. Fine. Next is initial position. It is, I think all of you know what is initial position. Say you are coming from school to you are coming from home to your school, so your home you can consider as the initial position, and school can be your final position, or you may consider school as the initial position. After school you have to go from school to home, so you can consider school as the initial position, and your home can be the final position. So you can see what is initial position, final position, it is written. You may read this. Next is displacement. So displacement is the shortest distance between the initial and the final position. So definitely it is independent of the path followed. I was giving you the example of that movement of an object from Numaligarh to Jorhat via Numaligarh Tiniali or via Golaghat. So in these two cases you could see that uh, path covered by the object is different, so distance also it is not same, distance covered also not same, but displacement, as it is the shortest distance between initial and the final position. If we consider this example, your Numaligarh can be the initial position, Jorhat can be the final position. So what is the shortest distance? How to find the shortest distance? You have to join initial position and final position by straight line. So definitely that remains the same. So displacement is independent of the path followed. Fine. So it is the shortest distance. Again, the SI unit of displacement is meter only, because uh, it is also a distance, but it is the shortest distance. So can the distance and displacement be equal? So you can see this. What is the condition under which distance is equal to displacement? I want you to read this. I am giving you one example on the basis of that number line. So you can see this example, you can read this, followed by problem 1 and problem 2. Please go through this. The next is scalar and vector quantities. You should know what is a physical quantity. Physical quantity means the quantities which are physically measurable. Like mass is a physical quantity, you can measure mass. Length is a physical quantity. Okay, so physical quantity is expressed in terms of two important things. One is magnitude and another is unit. So already we talk about three different types of systems of units, MKS, CGS and FPS. Already I told you. So physical quantities, if I say mass example, or weight or time, whatever. 5 second, if I say 5 second, so 5 is the magnitude, is the numerical value, second is the unit. Fine. 10 kilogram sugar, 10 kilogram sugar, 10 is the magnitude and kilogram is the unit. Or 10 gram sugar, 10 is the magnitude, gram is the unit. Fine. So scalar physical quantities are those which are represented by magnitude only. Okay, magnitude only. That means you need not mention the direction. Like for example, distance. How much distance you have covered while going from one point to other, say 20 kilometer or 5 meter. So you need not mention the direction. So distance is a scalar. Speed, with what speed you are moving, say 10 kilometer per hour. So you need not mention the direction. So speed is a scalar. Time, what is the time now, say 10 o'clock. So you need not mention the direction, it is not important at all. So these examples you can see distance, speed, time, area, temperature, etc. These are scalar physical quantities. Fine. Similarly, the physical quantities which are represented by both magnitude as well as direction are called vector quantities. So you can uh, see these examples. Velocity is a vector quantity. Displacement, so you are moving from one point to other. So how to write how much displacement you have made? You can write that 10 kilometer towards northeast or 5 meter towards south. Fine. Force, say example 5 newton towards left, 5 newton towards right. So you should be able to mention the direction. Weight, okay, you have to mention the direction. Similarly, the acceleration also. These are the physical quantities where you have to uh, use both magnitude as well as direction. Fine. So this is scalars and vectors. Next is uniform and non-uniform motion. So in case of uniform motion, the body has to cover equal distances in equal intervals of time. I am giving you one example here, please go through this. And in case of non-uniform motion, the body has to cover unequal distances in equal intervals of time. In our next class, we will see how to draw a distance time graph for uniform and non-uniform motion.